This is CPM Precalculus, Chapter 1, number 67. So here we're asked to find the equation of the graph below. Okay, so we have A and B. So we want to find the equation stating the parent graph and describing the transformation. Okay, so this, so far in this chapter, we've basically looked at 6 parent graphs. If you examine them, this one looks like our parent graph of y equals 1 over x, right? So we're looking at A here. And y equals 1 over x looks like this, but it's over here. Oops. The x and the y axes, right? It doesn't cross them. And it's more like this. So this graph then, if you look at it, the new line it doesn't cross is right here, right? So it doesn't cross this line and it doesn't cross this line. So this midpoint, this origin in our axes moved to be right here in our new graph, whatever this is. And so it shifted left and down. So we could see from y equals 1 over x, which is our reciprocal graph, right? Reciprocal graph. That's the parent. To our graph up in the graph here is it shifted. What did it shift? Left by 2. 1, 2. Shift left by 2 units, as well as down by 1, 2, 3 units, right? Shift down by 3 units. Okay, so how do we get the equation for the graph if we know this is our parent and it went through these 2 transformations? Remember, transformations are just the way that the graph changed from the parent graph, right? So this is the parent. And it went through these transformations, so our new baby graph, or the new graph, is going to be looking like the parent graph, but shifts left by 2 units. So we know if we left by 2 units, we know is going to basically change the function to f of x plus 2, right? This is going to shift it left by 2 units. Shifted down by 3 units, we want it to be f of x plus 2 minus 3, right? Here, let me erase this so we can see that. F of x plus 2 minus 3, right? So that's going to be shifting down by 2 units here, and shifting left by 2 units here and shifting down by 3 units here. Okay. So our input, right, if y is now, instead of y, if we say it's f of x, right, is equal to 1 over x. Now, let's just say we want it to be, our new graph is going to be, I'll call it y2, is just going to be f of x plus 2 minus 3, right? And all this is saying is the argument here is going to be x plus 2 instead of x, and then we're going to subtract 3 from whatever we get. So looking at our parent graph is just 1 over x, right? So instead of x, we're going to write x plus 2. Okay? And then we subtract 3. So this is now our new graph here. And it's equal to y2, or whatever we want to say it's equal to, right? So this is part A. Okay. And now part B. Part B, okay, we look at our 6 parent graphs, and this is just the parabola one, right? So our initial graph is part B. We have the parent graph being y is equal to x squared, right? That's our squared function or our parabola, okay? And we know that, okay, so this is the parent, and the parent starts here, 0, 0, and it goes like this, right? It just goes up, and it goes up here. So this is the parent graph, and our vertex is at the origin, So the vertex, what are we doing here? Okay, we're shifting how many to the right and up, and also reflecting across our x-axis, right? So we know reflecting, right, across the x-axis. So once we reflect across the x-axis, it's going to be going down like this, right? And then we want to shift it 1, 2 to the right and shift 1 up. So shift right by 2 units and shift up by 1 unit. Okay, so we know, let me just move to the right a little bit. So we know that in order to reflect, okay, so again, if this is f of x, right, is equal to x squared, we know to reflect across the x-axis, we want to say our new function, y2 is equal to negative f of x, right? We know that if we have the negative on the outside, it's going to reflect across the y-axis. The x-axis. Okay, and then if we want to shift right by 2 units, that is where we put in the input. So let's call it y sub 3, right? We have the same function here, but we want to right means we subtract 2 units, right? So it's f of x minus 2, right? So changing the argument to x minus 2 shifts it right by 2 units. And then up by 1 unit, so y4 is equal to negative f of x minus 2, and then up we add 1 on the outside of the function. Okay? So how does this look? Well, basically, what do? We have our new y4 is equal to negative f of x minus 2 plus 1. Okay, so f of x is defined up here to be x squared. So it's going to be negative, right, of, instead of x, we have x minus 2 squared plus 1. Okay, so this is our new function that is graphed here in black. Okay, and our parent function is here in blue, is x squared, the squared function. Alright, so this ends chapter 1 of Precalculus from CPM number 67.